Hello everyone, this is Suresh Kumar, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So today we will discuss about the unit hydrograph. So previously we discussed about what is meant by hydrograph, different type of the hydrographs will be discussed in the previous lectures. Now we will discuss about the what is meant by unit hydrograph and types of unit hydrograph. Let's see that one. What is meant by unit hydrograph? When the unit hydrograph, before going to enter into the unit hydrograph, let us some small review regarding the what is meant by hydrograph and unitograph like that. So hydrograph is nothing but a graphical representation of the presentation instantaneous of the runoff or discharge with respect to the time. Hello everyone, this is Suresh Kumar, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in the previous lecture, we discussed about what is meant by hydrograph and types of hydrograph will be discussed in the previous. Now we have to be entering the topic as unit hydrograph. What is meant by unit hydrograph? A hydrograph, before going to enter the unit hydrograph, let us discuss some basic fundamentals of the reviewing of the hydrograph. So what is meant by hydrograph? Hydrograph is the graphical representation of the instantaneous of the runoff or discharge calculation with respect to the time. So sometimes it is also known as storm hydrographs. Another we call it as the storm hydrographs also called it as. And comma flood hydrograph are simply we call it as hydrograph. Both are the same. Storm hydrograph and flood hydrograph, and simply this is a hydrograph. Let us see the hydrograph represents the what is we call it as hydrograph. We call it as runoff, direct runoff, base flow will be occurring with respect to given time or duration, whatever it is. It is also the distribution of the total runoff with respect to time. Certain point can be measured. Let us see these the characteristics of the region of the schematic diagrams on the hydrograph. The hydrograph is graphical, as you know, the graphical representation may be too many times single peak and multi-peak of the graphicus, and the multi-peak hydrograph is also known as a complex hydrograph. Multi-peak hydrograph is called as complex hydrograph, right? So let us see that another one. What is meant by etograph? What is meant by etograph? Etograph is the graphical representation. It is also graphical representation that shows the distribution of the rainfall instantly or the specific time of the period during the rain event. So we call as. It is commonly used for the hydrology and the meteorological analyzing the precipitation of the patterns. So understanding this the water resource management of the flood analysis. So let us see the hydrograph. The graphical representation of the shows the distribution of the rainfall intensity. That is the difference between the hydrograph and the etograph. Rainfall intensity. That is the time within the time period as usual. So what is the keynotes features of the etograph? Let us see that one. X-axis will be the giving the time. So years or month or the days, whatever it is, hours. Whichever is called as given the x-axis, and the y-axis rainfall intensity will be calculated here. Intensity of the rainfall will be here. Etograph will be represented like that. Okay, right. This is the etograph. Next, y indicates the rate of wind and the millimeters or centimeters of the. It can be per hour or inches per hour. Next third one is bars or line plot. Rainfall intensity is the plotted as vertical bars as the curve as the time of the interval. Next, let us see that one. This is the etograph. Etograph represents as time hour, and here is rainfall intensity centimeters per hour or millimeters per hour, whatever it is, we have to be as per our requirements. So this is the intensity 0.2, 0.2, 0.6 and 1. So rainfall excess, that is rainfall. This is horizontal line. The horizontal which is the connected here, and the above datum line we call as the pi index. The bottom is we call it as pi index. and W index. So this is the one point has to be represented the baseline of the rainfall, and above the line which is already crossing, this is called as rainfall excess. We call it as rainfall excess, nothing but we call it as the runoff. Rainfall excess, nothing but runoff. Next, time of the types of the heatographs. The cumulative high heatograph and displays the total accumulation of the rainfall time intensities at the heatograph. Focus on the rainfall intensity of the specific intervals. Specific intervals. What is the intervals? Let us given the hour spaces. Time in hours. Let us see here. We have to be time in hours. Right. Next, next storm units uses of the heatograph. What is meant by use of the heatograph? Heatograph is nothing but a storm analysis. We have to be analysis of the storm analysis can be represented here, helps to identifying the peak intensity and also duration of the storms will be calculated. Then next one is flood precipitation. Next, flood prediction. Sorry. So it can assist the simulating the predicting the potential floods of the scenarios. Next, what when it can be used for the irrigation projects design. Irrigation structures will be designed. The heatographs will be calculated. Thus, previously designing of the efficiency of the water and distribution of the systems. Next, what is the urban planning? So, urban planning is used to evaluate the impact of the rainfall and on the urban area and the drainage system will be designed. The heatographs can be used. Next, unit hydrograph analysis. What uses rainfall analysis? So, it help you visualize analyzing the. This can be used for the heatograph. It can be used for the hydrographs. So, the first one is rainfall analysis. Rainfall analysis for the hydrograph uses. How the rainfall analysis? The rainfall analysis can be represented the water which is collected, which forms through the small streams and runoff will be calculated. So, help to visualize and analyzing the intensity and also distribution of the rainfall. So, during the storm event. So, what is we have to be collected? What we have to be calculated the runoff? Because on particular catchment area, how much water can be according to the rainfall intensity and rainfall and data. So, we have to any of the construction of the hydraulic structure. So, hydraulic structure we have to be useful for the calculation of the runoff is the very important. During the analysis only, we have to construct which type of the structure we have to be constructed is the very, very important on that one. Next, flood precipitation. Next, flood predictions. Flood prediction nothing but used to input the flood forecasting methods and particularly estimation of the surface runoff. As we know that the surface runoff is there and subsurface runoff. The surface runoff which is all water is flowing. After all the losses, the water flowing inside above the ground, the excess of the water flowing we call as the runoff, and that is the surface runoff. And subsurface runoff is nothing but the runoff which is the flowing inside after the infiltration percolation. The water is flowing in the inside the ground. We call it a subsurface runoff. Can be analyzed. Next, irrigation design. Third one is irrigation design. Irrigation design nothing but here this is the designing of the drainage irrigation systems as well as providing the data of the rainfall patterns. Next, storm water management. What is my storm water management? The storm water is nothing but what we call storm water. The rainfall which is added some impurities in the above the ground we call storm water, and circulating of the designing in the urban areas drainage systems will be the handling the peak of intensities and the effectiveness. That is the storm water management. Storm water, the runoff with the heavy rainfall will comes. The water which is flowing above all the roads and also mixes some of the impurity dust particles, whatever it is, that can be also mixed. So this is called storm water intensities can be calculated. Next, rainfall and runoff studies. So this is very important point on rainfall and runoff state, where we have to be provided the basics are determining the relationship between the rainfall and resulting the surface runoff we have to be calculated. So these are the calculation of the rainfall as well as the runoff will be calculated here. Next, flood hydrograph uses flood analysis, river basin management, reservoir operation, urban hydrology, impact assessment. So let us see that one, flood analysis. In the flood analysis, what happens? The floods which also comes during the heavy season, the study of the time peak of the duration of the floods will be there taken, and river basin of the management helps to understanding the river behavior and the planning sustainable of the urban water basins. So this is the river basin of the management. Drought studies. What about drought studies? Analyzes the low flow conditions to assess the drought service service. Next, reservoir operation. In the what is how it can be used the hydrograph reservoir operation. So this will guide the reservoir to decision making of the about the runoff the water which is collected during the time peak time, and the volume of the inflow will be calculated only during the runoff. Inflow will be calculated. So based on the inflow and outlet, we have to be dam will be the operating, how much water can be flowed in the upstream side. Above the gates will be opened due to the heavy floods. This can be judged by the reservoir operation. We call it as reservoir operation to the gates or gates, whatever it is. So this is another thing. Next, urban hydrology. As I told, urban hydrology also helps design the mitigates measures like retention ponds and channel improve the urban areas. Some of the ponds will be the urban areas will be the one of the useful. Next, impact assessment. What is the impact assessment? It evaluates the effect of the land use changes such as urbanization, deforestation on the water flow. Next, urban hydrograph helps to surface runoff catchment resulting of the unit hydrograph usually. So unit hydrograph is the hydrograph which is the catchment resulting from the unit hydrograph. Stay 1 centimeter rainfall is excess the effective of the rainfall. We currently not watershed in the uniformly watershed and uniform rate of the specific duration. So that is the one of the point. Next, the constant of the watershed. The constant of the watershed can be used help to determine the volume of the direct runoff and any of the storm of the occurring of the catchment. So what is the assumptions of the unit hydrograph? What are the assumptions of the unit hydrograph? Very important. First assumption is the uniform intensity of the rainfall with a specified duration. So it means that the intensity of the rainfall on particular duration of the period we have to be find out. It is peak discharge of the morning or 2 p.m. or whatever it is. The discharge at night, we have how much the water can be run off in the discharge on particular time will be noted, intensity will be noted. Next, effective rainfall is uniformly distributed in the watershed. Next, base of the time duration of the direct runoff hydrograph is the constant. These are the sum. Let us see that direct. So this is the SR hydrograph, direct runoff. So direct runoff hydrograph. So this is the hydrograph x1, x2, x3. These are the base period. It can be peak will be changes of the different of the levels of the base period is the constant level you have to be find out. So base period it is the peak discharge and slowly it can be comes during the on particular time it will be the reduced. So these can be represented in the by graphical representation is the very important to showing that. So these are the x1, x2, x3. These are the different type of the levels. So the starting point from the peak it will becomes and can be discharged, and after the few hours it can be raised and again it can be there is a peak discharge you have to be calculated x1, x2 and x3. So next unit hydrograph, direct runoff hydrograph, effective rainfall watershed is always not very time. The relationship between the direct runoff and effective rainfall is example of the effective rainfall of x into centimeters generated by the meter cube direct runoff, and 3 times will be generated by the 3y, 3x and 3y of the meter cube, 3x and 3y of the meter cube. Next, derivation of the unit hydrograph. So next derivation of the unit hydrograph, step 1, separate the base flow from this method. First we have to separation of the base flow. As we know very well, the unit hydrograph, the base flow will be separated. So this is the, by using the base flow separation. So base flow separation, this is why we call it a pi index, right? So base flow separation, the separate of the base flow of the any of the time, and determination of the volume of the direct runoff, and determination of the effective rainfall watershed of the area. And next step for determination of the ordinates of the unit hydrograph, and ordinates of unit hydrograph is equal to direct runoff hydrograph of the ordinate by effective rainfall. So that is the they can plot the unit hydrograph like that. This is the sum of the points you have to be remember by the preparation of steps you have to find the while the unit hydrograph. The derivation unit hydrograph step and separate the base flow as usual. Determination of second point volume of direct runoff, and third point determine effect of the rainfall or watershed of the area. Next determination of the ordinates of the unit hydrograph will be the take it, and the ordinates of unit hydrograph is direct runoff and ordinate by direct runoff. This is the sum of the points you have to remember. Then unit hydrograph is can be used where you have to be used the unit hydrograph. The unit hydrograph used to get the hydrograph for the other rainfall events. For example, if 1 hour unit hydrograph is taken, it can be used for the complete hydrograph the 3 hours of the event. That's why you have to be example calculation in the next unit of uses of the unit hydrograph. Next, the development of the flood hydrograph. Use design hydraulic structures such as the bridges, culvert, flood forecasting warning, and flood flow records of the use of the rainfall. Next, unit hydrograph. An unit hydrograph is the hypothetical of the response of the watershed of the unit of the per unit area. Hydrograph, direct runoff hydrograph can be resulting of the 1 unit centimeters of the effective we know well. 1 unit of the centimeter will be considered for the unit hydrograph. Rate of unit period of the time for the unit period of the time. Next, apply the direct runoff and the surface runoff as usual. So let us see the unit hydrograph. This is the direct runoff unit hydrograph. So of course, this is the basic base flow separation from one point to another point. The influence rainfall excess and also the TP and TR total points. We will have to take the base flow separation, and the discharge here you have to take per hour per second, and of course this is take it as I told the base flow. Then the after separation the x-axis will take it as the time period. So time period 1 hour, 2 hours, 3 hours, 5 hours like that. So after the base flow separation, how much the rainfall will be the intention. Here TP, the TR is there. So the calculation based on this 1 centimeter rise of the one, you can be able to take it as the consideration. So what are the basic assumptions of the unit hydrograph? The effective rainfall uniformly distributed within the duration. That is the basic fundamentals of the unit hydrograph. So amount of runoff resulting 1 unit hydrograph, where it is 1 centimeter or 1 mm, 1 feet, etc. So for this one, the effective rainfall uniform distributed within the same you have to be assumed. That is the unit hydrograph. In the previous it may be changes, but we have to be unit hydrograph. What is the difference between the previous hydrograph and unit hydrograph? We have to consider it as 1 centimeter of the depth and separation will be considered. Next, the effective rainfall is uniformly distributed over the whole drainage of the basin. The base duration of direct runoff is hydrograph due to an effective rainfall. Unit hydrograph is the constant. The ordinates of the direct runoff unit hydrographs proportional to the amount of direct runoff unit each hydrograph for the given basin. The runoff hydrograph is given the period of rainfall reflects all combined physical characteristics of the basin, that is called time invariant. Time invariant. Next, features of the unit hydrographs are, what are the features of the unit hydrograph? In the features of the unit hydrograph, let us see, it has to be rising limb, as I told. This is we call it as rising. So this is called rising limb. Rising limb. Next, let us see that one. So rising limb. It is also known as increasing of the limb, or rising limb, whatever it can be said. Next, this limb will be the, so then it indicates the increasing the discharge of the over time during the initial of the infiltration, and that has to be occurred during the rainfall. The initial losses also leads to higher rates of the discharges. Initial loss take it as higher rates of the. The radial limb is also known as radial limb and indicating the maximum water storage due to the decreased discharge of the runoff. Decreased discharge of the runoff will be the radial limb is also known as the descent limb and indicating the maximum water storage due to the decreased discharge of the direct runoff. Next, the crest segment, which is the segment of the indicates the maximum discharge due to the drainage runoff, is also referred as peak of the discharge is given the storm. Peak discharge are given the storm. Next, assumptions of the unit hydrograph. So the time variance of the uniform distributed hydrograph. No valid linear response has been considered to the unit hydrograph. And third, the base period of the hydrograph is effective rainfall uniformly distributed as given the time period. And then the effective of the uniform distributed the given the period time. Next, effective rainfall is also uniformly distributed throughout the year. That is the one of the assumptions. And this is also here distributed over the given period of the time. And effective rainfall also uniformly distributed throughout the year also we have to be considered. That is the assumptions of the basic assumptions of the unit hydrograph. Now, so what are the limitations of the unit hydrograph? The limitations unit hydrograph is the types. The unit hydrograph method is applicable for that area. Major portion of the precipitation of storm variation and also the principle of the variable sometimes does not hold the basin of the characteristics will be changed and adjustment will be as the seasons. Next, unit hydrograph, the linearly principal storm and the unit hydrograph derived from the small rainfall events hydraulically has lower peaks than the derived from the larger, and the storm of the selecting of the always sorted out, and as well as it can be rainfall intensity long duration. It can be long duration can be unit hydrographs can be selected. Next, unit hydrograph is only applied the drainage basins as the small areas, does not the longer areas. So that is the very, very important. That is what you have done with small areas and not to be larger areas. That is the unit hydrographs. Next, derivation of the unit hydrograph. A number of isolated hydrographs will be sorted out the rainfall excess and approximately the from duration 0.9 to 1 and selected from the study of the continuously gauged runoff of the stream. For each of the surface runoff hydrograph, the base flow is the separated. The area of the direct runoff evaluated, the volume direct runoff is divided into the catchment area to the effective rainfall, and the ordinates of the given, the ordinates, x coordinates, y ordinates, ordinates of the given in the space we call direct runoff hydrographs are divided into effective rainfall, and the value ordinate will be the. So next, the ideal duration of the unit hydrograph one which is small fluctuations and intensity does not have any of the significant of the runoff, and the duration of the unit hydrograph should not be exceed 150 to 1/3 of the basin of the lag. So that is the general catchment of the, we have to consider it at 250 square kilometers and 6 hours duration. So let us have to take the 2 hours, 6 hours, 12 hours duration of the period will have to consider. Like that, it can be covered. The areas can be bifurcated into 6 hours. Is generally 6 or 12 hours. The unit hydrograph will be catchment area from this. Generally, 250 square kilometers, we consider 6 hour span will be the taken. Why you have to run off will becomes and time will be taken in the small streams and can be flow. The flow duration will be also there. That's why we have to take the consideration on particular area 250 kilometers. Next, unit hydrograph from the complex storms. So there is some complex storms is there. The simple of the storms available of the data complex. The long duration will be have the derive the unit hydrograph, and problem is decomposed measured the composite hydrographs and the base flow. The common unit hydrograph is the base appropriate during the exits. So synthetic unit hydrograph. Next, what is meant by synthetic unit hydrograph? So hydrograph, unit hydrograph. There is a synthetic unit hydrograph. Synthetic unit hydrograph is derived that the rating of the hydrograph characteristics such as peak flow, base time, and with watershed characteristics. What are the watershed characteristics? The availability of the rainfall and the soil conditions and temperature, wind velocity, and evaporation or temperature, wind velocity. Like that, you have to be some of the criteria will be affected in the catch on this particular area. Next, especially the soil conditions. Soil conditions, how it will be affected. Next, using the dimensionless unit hydrograph based on the watershed storages. Next, need to unit hydrograph. Unit hydrograph is applicable for the gauged watershed for the point of stream and data measured for locations of the stream the same. The watershed for the nearby watershed synthetic procedures can be used. So let us see synthetic unit hydrograph. There is standards of the method can be used to apply. Here lag time, we have to be lag time TL, unit hydrograph duration TR. So TL is equal to lag time and TUH is equal to TR and UH peak discharge is equal to QP. Hydrograph time is 50 to 75, 50 and W is 75 on the peak. What is meant by lag time? Lag time is the time the center of the rainfall access to the unit hydrograph in the peak. So we call as the lag time. So this definition is very important. So time. So how can we calculate the lag time? There is a formula is there. CTC is equal to C1 and CT into C into CCL into whole to the power of 0.3. We call it as the where he is the LC is equal to lag time. So let us see that one. C1 is equal to 0.75 to SI into 1 English units. Next, CT is equal to coefficient of which the functions of the watershed will be taken as time. So TL is time in hours as usual. 18 is equal to steeper of slope of the CT is the smaller. L is equal to length of the mean channel. MI and LC is the length along the main channel and the point nearer to the watershed of the set point. So unit hydrograph TR. What is meant by TR? TR is nothing but time of duration, time rainfall. TR is equal to TL by 5.5. Where TR and TL are the hours of the duration of unit hydrograph. TR is the lag time and lag time is hours. Lag time needs to be adjusted as TPL is equal to TL plus 0.25 TR minus TR. So this is the application for the unit hydrograph, and where LTR is equal to registered lag time, TR is equal to design unit hydrograph. Next, unit hydrograph peak discharge. If it is the unit hydrograph peak discharge, what happens? Here the C2 is equal to value take it as 2.75. So I will explain all those things in the during the diagram. So there is the 6.5. The coefficient of the according to the value will be taken as storm instant and 0.4 to 0.8. Specific discharge will be taken as meter cube per second per kilometer square. The complete actual discharge is equal to AX into Q to the power of P. Then QP is equal to C2 CP by TPR, where C2 is equal to 2.3 value take it as, and the SI units of 640 for the English. CP is equal to coefficient of accounting of the flood wave of the arrangement of the conditions of the, of course 0.2, 0.8 will be taken as. QP the cube specific discharge discharges meter cube per second, the units is meter cube per second in kilometer square, and the complete actual discharge is equal to A into Q into P. So applying this formula, I have to do the peak discharge will be the calculated here. Peak discharge will be the calculated. So the base time base is equal to base time or base assumption is equal to unit diagram C3 by QP as we discussed. Here TB peak hour C3 is equal to 5.56 SI units of 12.90 of the English units. That is the unit diagram width. Width we are going to calculate W by 75, that is equal to C by W 75 by QP to the power of 1.08, or W50 is equal to CW50 by QP to the power of 1.0, where CW is equal to 1.22, SI into 450 for the English CW, and 2.14 SI into 750, and W50 W75 are the hours of the use taken as 1/3 of the width of distributed before the unit diagram, and 2/3 of the peak remainder to take it as the volume unit diagram for 1 centimeter of 1 inch. So that is, let us see, W50, W70 are the hours, peak hours have to be considered. Usually 1/3 width of distributed of the unit diagram, peak of the 2/3. Let us see, this is the diagram regarding this one. So that is the 1/3 is taken as 1/3 here as I shown, and this is 2/3 is also given 1/3, 2/3, and the unit of the peak discharge of the duration of the basin lag, that is equal to divide to discharge in the cubic is taken as in one side, and the base flow T is days and number of days to number of hours is there, and is equal to TP by 5.5 cinders, and CP is equal to 640 CP by P, 3 plus TP by 8, and W by 75 will be taken as, why W by 75? Well, as we know that 1/3, 2/3. 1/3 is taken as a one. W50 is taken here. In such a particular situation, we have to take it as W by 50, and here the width will be the peak discharge. We calculate a W by 75. So based on W by 50, then this is some of the distance between the rising limb or the falling limb to take the percentages will take as a peak value from the center. So there is some formula is there. W by 75 is equal to 440 QP by A whole to the power of 1 minus 0.18, and W50 is equal to 770 QP by A whole to the power of minus 0.1 time. So these are the basic fundamentals, and also they give the formula. By applying these values, you have to find the unit diagram calculations, and synthetic unit diagram calculation will be calculated. So today we discussed about the hydrograph, unit diagram, and the uses of the unit diagram, and what are the assumptions of the unit diagram, and also synthetic unit diagram. How we have to take the values from the different applying the formulas will be discussed today, and I hope you understand. Let us next sessions we have to take the another important topic. I will meet. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.